In this video, we are going to describe a term that is called as function. As you know that in every field we have a basic term that we use to describe other objects or values. So in calculus, we have a term that is function to describe our objects or formulation of objects. So I will elaborate the definition of function with the pictorial explanation. Suppose I am taking a car and it completes two paths. As in first, speed of car is low, that's why it completes a small distance with respect to time. And in the second, the speed of car is high, that's why it completes a larger distance. So we can say that our speed depends upon the value of distance of the car with respect to its time period. Next, I'm using two values that is used in our, sorry, it's a bit higher. So the two values that I use in function, one is an independent variable and second is dependent variable. Let's see which is independent and independent. In this pictorial explanation, we say that S depends upon the values of distance and time. If we have speed is like this, distance over time. So if we have both the values of t and t, we can easily find out the value of s, that is our speed. So in this we can say that s is our dependent upon these two independent values. So s is an dependent value and d and t, that is our distance and time, are independent variable. Next, we will consider another definition of a function. Suppose we have a set of values t and a set of value of phi. So in it, you can see that a function from a set t to a set y is a rule that assigns an unique element y is equal to f of x belongs to y to each value of x that belongs to t. You can see that this over x and here lies our y. So when we put every value of x1, x2 that belongs to set d in the function y, that we will get a unique element from putting these value of d. I repeat again, When we put each value of x that belongs to D, we will get a unique element y that belongs to set of y. Next, we will see what is the domain and range of a function. The set D of all possible input values is called domain of the function. All the values of x1, x2, x3 that contains in D set that is going to be put in the function of y are called as domain of function. And the set of all f of x as x varies throughout the D is called the range of the function. And what is the range? When we put x in the function and we get a value, we can say that that value is going to be our range value or the element that contains in our set y. Suppose I am taking a function, you may say that f of x is equal to y, and this is our function x plus 2. Suppose I am putting x is equal to 0 and this will be equal to y is equal to 2. So this is our range value that must contain in our set of y, and x is our 0. So next statement is this: the range may not include every element in the set y. So they were saying that range must have all those values that we will find out after putting the values from the domain. You will get a clear idea from this. If we put the input from the domain then into the function f, we will get an output that is called our range. So there is an arrow diagram over here that describes the functionality more clearly to you. Suppose this is our domain and it contains x and a element, and when we put x into the function value we will get f of x, and when we will put the value a into the function this we will get a value of f of a. And you can see that there are these points that doesn't belong to any function. That means that is not the value of range. Suppose we have x1 over here and x2 over here. But when we put x1 and x2 into the function, we will not get the values that is present in our set of y. A function from a set T to a set y assigns a unique element of y to each element in D. This is the same as the definition of function. So I hope that it clears the whole definition of a function. Here is another point that I think so that is important. Domain may be restricted by context. Suppose I'm giving you an example of a function a is equal to pi r square. Pi r square. So a is our function that is depend upon the values of these two, radius and pi values. These both are independent. Okay, now we will move to the first the restricted context or unrestricted context of a domain. Suppose if I say that R must be equal to and greater than 2. In this way, our domain is restricted. But if I say that R belongs to any value of real number, then it may contains negative values. It may contain 0 or it may contain positive values. So this is our restricted domain. So if in it I have given you the domains, but if they didn't give you the domain, suppose I am taking another function that is equal to 1 over x. So in this you can see that your x maybe have any value except 0. X must not be equal to 0 because it will give you an undefined value. So in this way you can see that our domain that contains the x value is restricted by the context.